about the implicit differentiation questions, but before we do that, are there any that you encountered that you're like stumped on, or Rom royalty? Please get your hands out.
Can you do like 17 or 20 or just one of those styles?
Styles.
Or one more of those?
We did 20, so then I have completed that page. That would make me happy.
Trace of the mean number. That's so epic.
21?
With 21? Well, Aaron, you say 17 and 20. Those are like not even very similar questions.
Okay, well, okay.
How about 21's a good one? I mean, 21's kind of similar to 20, right?
I just wanted one of those.
So
One of them.
you've got your graph is
Yeet.
oh buckets.
There's two of them right there. 3. This confuses me.
So
It's like one of those
that
sloths.
did sound like a frog. Before you get into the details of this, you can get a rough idea of what the graph looks like, because who can give me 1 point that definitely lives on this graph? BT-dub. Yeah, good job. 0, 0. What is number? 0, 0 definitely lives on this graph. Plug in 0, you get 0. I mean, that's the only really like obvious one. You could, let's say, like, oh, if I plug in 1, I get 1 over e squared. Okay, we know that's positive. That's actually kind of nice. So we do know that it hits positive numbers. That last thing makes sense?
Yes.
I mean, 1 over e squared is not a very big number, but it does go positive. And then what's going to happen if e is big? What if e was 100? Negative. What's 100 divided by e to the 200th power? Roughly. It's roughly 0. It's positive, but it's like roughly 0. So this graph has to then, for large y values, it has to approach 0, right? Make sense? The harder part of this is, what does the left tail look like? Well, okay, would you count it as obvious to say that if x is negative, y is negative?
Yeah.
Hopefully, somewhat, if not obvious. It's just straightforward. Like, all right, this term is never negative, right? So a negative divided by positive is negative, and then as x gets more negative, this is maybe the harder part, is you're gonna have a big negative divided by a small positive.
Big negative.
So it's gonna be, you're gonna get big negative numbers on this side. So I think the graph looks something like this. I might be missing some kind of concavity. That's what the calculation's gonna show us, right? Like the details, but I think it's something like this. And by the way, here's a more nuanced thing, I guess, real quick. If a graph goes positive and then has to approach 0, there has to be a concave down to concave up thing going on, just geometrically speaking. Like, how else is that going to work out, right? You have a question?
So e to the whatever power can never be negative. That's
Yep.
like a thing.
Yep. This is so.
Yep.
So, what if you know this graph? It contains a lot of information. It tells you that for large x values, it's very large. For negative values, it's very small, and then it's always positive. Okay. So, calculus time. First derivative. It's actually not asking for the second derivative, so maybe we'll be fine. First derivative. Which rule do we use?
Quotient.
Quotient. You could do the product rule if you rewrote it like this: x times e to the negative 2x. In fact, that actually might make our life really easy.
Really?
Want to do it that way?
Sure. Yeah.
No, Kate says no. I don't want that. You sure? Come on.
No, let's try it.
Wait, you don't like product rule?
This
Why?
makes it so much easier.
Because
now you can
has
use
divider
The
line.
product rule. So you go a prime times b plus, what's b prime? This is my a, this is my b. A prime times b.
Negative 2e to the negative 2x.
Good, there's my b prime times my a. I'm gonna write it a little bit more nicely. So e to the negative 2x minus 2x. Okay, now this one, I really, well, I don't know. You could write it like this. So you see I could factor out this common factor? And I can do that one of two ways. I could write it like e to the negative 2x times, what's left over if I take that out?
1 minus 2.
1 minus 2x. And then I could move that on bottom if I wanted. Not like that's that important, but. Do we understand that?
Mm-hmm. I just wrote 2 negative signs.
Do you want to see the quotient rule way, Kate?
Yes,
Make it happy?
please.
Okay. Here, I'll do it kind of fast. So here's if you were going to do the quotient rule, we would have been back at this point. A prime B minus B prime A all over B squared, and then you'll notice that these all have an e to the 2x, e to the 2x. This bottom is e to the 2x times e to the 2x, so I can cancel out one of those. And then the top would, after I cancel that out, I get the same result. That's neato, isn't it?
Neato Frito.
Neato Frito. Frito, the king of snack, other than the potato chip.
Yes.
Who's in here telling me that Fritos are bad? Was it Trenton?
Those are not great.
Only the potato chip can come close. Oh, okay. Yay!
Jezebel.
Jesse's here. What up?
Not much. Yep. I don't know why you're here, honestly. You should just stay home and chill.
Honestly, I'm fine, man. It wasn't that bad. It was routine.
Routine.
No, truly, it was like the most like perfect. I got an IUD. Apparently, it was the most perfect that I could have gotten. Yeah. And so apparently, like, you know, it was fine. Cervix open. It was good.
Thanks. Jess.
So I'm doing fine. Have a lot of ibuprofen in me. Well, my normal cramps are like way worse than this. So this is fine.
Okay, moving on.
What?
Moving on.
I got it.
Hold on.
Jesse, here's why it's funny. I was being discreet when I was like, oh, she's at the doctor's office. But she might not want that.
Not
And you just come in here and be like, you know.
radical hippie leftist lesbian
Oh my God, oh my
socialist.
God.
I'm gonna come in and tell you
Anyway,
No.
where is our
Normalize.
critical value?
Jesus Christ, Jesse.
0. Trace says 0. Oh, wait.
That's a
So-
good bet.
Remember, you gotta look for any x value that makes this derivative undefined or 0. So
0.
the bottom can never equal, this can never equal 0, so there's nothing that would make this undefined, but if I plug in 1/2, I would take 0. So what does that tell me about my graph?
It looks right, yeah.
That's gotta be where that Humpty Dumpty was. It has to be at 1/2. Logically, there's no other.
Logistically.
Here's the thing though, I would say that drawing this graph
Intuitive.
is, we drew the graph before we did the calculus. For many people, the graph is more challenging to think through than just doing the calculation. That's for a lot of people. So this would have told you, if you didn't have the graph in advance, this would have told you that there's only one Humpty Dumpty. Now here's the thing, you might not have known, is it a me or is it a me? Is it a local max or a local min? How do you tell that? You gotta plug in. So if I plugged in like 0, for example, I would have a positive derivative. If I plug in 1, I'd have a negative derivative. Everyone cool beans with that?
Julio beans.
So that tells me my graph went increasing, decreasing. So if you combine, it doesn't ask us to find the concavity. And actually, I mean, this wouldn't be that bad to do the second derivative of, but because quotient rule would actually make it pretty easy. But this is enough to tell that, yeah, this graph can only have a single max. And Now, as far as like where is that inflection point, we could find that, but the question's not asking us to do that, so we don't need to do that. Now, to find a local extrema, you can't just say 1/2 though. You also need to tell us the y value, right? So how do I get the y value? Plug it back into the original function. So, in the table of values for the original function, when you plug in 1/2, so you'd have 1/2 divided by e to the 1, or 1/2e. So this point has coordinates 1/2, 1/2e. Cool beanies? Amazing. Lovely. Any local mins? No. So we have the increasing, decreasing intervals, and so on and so forth. So are we okay to move on to some neato stuff?
So it's a math.
What?
Oh,
It's just
It's a little.
Have we done anything else?
Nope.
I like how you're all discreet, like she's at the doctor.
I was trying to be
No, it's
respectful
very
to
nice.
your
It was
personal
very nice
information.
of you.
We're at, so whenever you do this process, you always ask the question, when will the slope equal 0? So when you set that equal to 0, if you want to be really algebraic about it, and you say I'm solving this equation, your first step would be multiply both sides by e to the 2x, and that would leave you with this. What we usually do in practice is the more familiar you get with setting things equal to 0, you start to realize that the bottom you can just get rid of it. Once you've considered asymptote values, you can just ignore the bottom, right?
Yes.
So
Yeah, abracadabra, it's gone now.
I think 32 is probably the first it's the first question that asks us about an implicit differentiation. Okay.
What are we doing? Huh?
We're gonna look at 32.
Okay, thank you.
It asks,
Thingy.
where does this graph have vertical tangent lines? This is an interesting question. What does that graph look like, first of all?
Well, it looks like a
Tall sine boys,
It's like a small sign.
big wavy boys,
Well,
Small
Elon-
ones.
small ones.
What's
What's a spirit?
it says,
Yeah.
so just, I think this is
And it's
the
not negative.
most fun part of math is before you start calculating, you just start to think what's going to happen if you have a curve and the squares of the y values have to equal the sines of the x values. Anyone have a thinky winky? What?
Explain.
It's not obvious. It's definitely
There's no negatives, right?
okay. What's no negatives?
The X, no,
Y
the
values.
Y values can't be negative, right? Or no, the Y values.
A
can be
y
negative.
value could be
The
negative.
X values.
So for example, just here, I'll throw a value out. Let's say x was, here's an easy one, 0. What's the sign of 0? 0. So what's the y value?
0.
Okay, we got 1 point.
1 point.
I'm gonna throw one out. Pi over 6.
That went way over.
What's the sign of pi over 6? I'm just setting myself up for despair here, I think. Just kidding.
Probably.
No. We can do this. It's is it 1/3? Oh, sorry.
Is it 1
It's
over
not,
2?
it's 1,
1/2. I'll do
yeah.
It's 1/2.
Oh.
Some key values to know, guys, are the sine of pi over 6 is a good one to know. What, Caleb? The sine of pi over 3 is root 3 over 2. And I'll throw one more in there. The sine of pi over 4 is root 2 over 2. Right?
Yeah. Sure.
These are good to know. I mean, if you're going into the humanities and you're like your last math class is going to be maybe like the one class you in college, it's probably not at this point that critical. But if you're going into STEM, this is kind of like like knowing your times tables helps you. Like if you don't know your times tables, math is like really a pain in the butt. This is like, dude, if you're going into higher level math, you don't know this stuff, you're just setting yourself up for frustrations.
All right.
I would suggest knowing
I'll memorize.
the basics. Just saying.
I'd say that, you know, these.
I want you to be happy. So, this is your pre-calculus stuff that you should definitely know, and then also, of course, you should go in knowing derivative of sine is cosine, derivative of cosine is negative sine, all the basics. Okay.
Yeah. Yeah.
Anyway, what I was getting at is, what's the y value then?
No, it's one. Plus or minus
Me
one.
too, Alyssa.
Positive 1/2.
Root 2.
Oh, yes. Okay, because it's
Right?
it's what.
Because the
yes,
square of the
root
y
of
value
that.
has to equal the sine of the x value.
Yeah.
Well, the sine of pi over 6 is 1/2, so y has to be the square root of 1/2. But wait, y could also be the negative square root of 1/2, right?
Yeah.
No, okay, confused?
Yes.
We can-
Mr. Hall, is this the function?
I like your okay.
Does this make sense or no? Are there any questions on this?
So Mr. Hall, is this function just like points all the way through?
No, it has lots of continuous parts and lots of parts. Well, I'll get to my point here, I guess, which is I'm going to throw a value out like this guy. So this would be pi plus an extra 1/6 of a pi, for example. So that would be 7 pi over 6. What's the sine of 7 pi over 6? Negative 1/2, because the y value is negative. Can that ever work out? Can the right side of the equation be a negative number?
Yeah.
Not unless you want to make it a complex y function. We're not doing that. So this would just be
So it can't be correct any time that it's in the bottom half of the unit circle. It's not, what's it called? G&E does not exist. Undefined. For fuck's sake, I didn't think of that word. Really?
okay. So the point I'm trying to make is there's going to be regions. There's going to be regions where this graph doesn't even exist, right? The graph doesn't have a graph, or there's no curve, right? And there's also going to be a symmetry where for the x values that are okay, there's going to be 2 y values, right? So there's going to be a nice symmetry to this graph is the point of it. All right, for funsies, let's get the, well, not for funsies, it's the question. Where will this have vertical tangent lines? Well, now you might have an idea, like, well, if it has perfect symmetry, if it's going to be symmetrical over the x-axis, then it stands to reason that the vertical tangent lines will be in a certain location. But anyway, derivative time. What's the derivative of y squared? 2y prime. Implicit differentiation, right? Every time you're taking the derivative of a function, you gotta use the chain rule. Yeah? Derivative of sine of x is
Cosine.
cosine of x. There's no x prime because there will be eventually. If you want to talk about, there's particles moving along a curve and we're going to take derivative with respect to time. If times are variable, then x will be a function. Does that make sense?
With respect to
So
time.
this time we're looking for this. We're talking about dy over dx. We're talking about
Yeah.
slope.
So
With
we're
the
looking
respect
for
to
the
x.
y value.
What, Alyssa?
Never mind. I understood what you meant. Don't worry.
So this would be my equation. Y prime is equal to the cosine of x divided by 2y. When do I get a vertical tangent line? When the slope is undefined, right? So a vertical tangent line tells us, or it means that the slope is undefined. The slope So that would mean that 2y equaled 0. What does that mean? It means the y value has to be 0. Well, when does the y value equal 0?
0.
Plug in 0 there. Whenever the sign of x is 0. But wait a second. How many numbers have a sign of 0? Quite a
A
few,
lot.
right? A lot. There's an infinite number. So let's describe that set of numbers. We already got 1, 0. When's the next time we get a sign value of 0 on the unit circle?
Pi.
Pi. Could I also have gone the other way? Could I have gone clockwise and got to negative pi? Very good. Yeah, very good. Plus or minus n pi. That would be just listing them out. I go 0, positive or negative pi, positive or negative 2 pi, and I'd say, oh yeah, I guess really it's just any multiple. Well, I can just say n pi and then let n be negative. Any negative natural, any natural number or any integer. Sorry. Here, I'll be really fancy for you, just because you're worth it. N
Give it to me, baby. I'm worth it.
pi, where n is an element of the integers. This is not
Write
really
it
in the
not in fancy way.
what?
Is not fancy way the one above.
This is more just like this
Like
enumerates the
general
list.
way.
This is fine. This is totally fine.
Good.
You don't have to know this, but just if you want to
what
flex,
What does the
Planning
fancy
on
Z
it.
mean?
means the set of integers.
The
So this
depth
reads-
of integers.
This reads
This is-
x is some number times pi, where that number n is any integer. So 0 plus or minus 1 plus or minus 2 plus or minus 3.
Beautiful.
I'm going to show you the graph. Anyone have it in their head of what the graph looks like?
I don't know.
Maybe.
Semicircle with some parabola.
A semicircle with some parabola. That's not bad.
I think it's a continuous mustache.
So think about a graph that's symmetrical along the x-axis, has gaps.
It's gonna be like half.
I'm gonna write that down.
Well, maybe it is.
Hey.
Look at that. That's weird.
Whoa.
Well, I wasn't.
Wow.
When I
quite
change
there.
the scale, it's
But-
really weird. I can go like change the y-axis to be like -1 to 1. And zoom out.
Oh, yeah.
Whoa, looks really weird.
I like the original one better.
Well, now it looks like a sine wave. So I don't know. Maybe that was dumb.
Yeah, that was dumb.
Dumb.
Gosh,
Dumb.
Anyway,
Paul.
so they're these weird little. I don't know what shape that is. I would. No, they can't be ellipses. Can they?
They're slightly squished.
Yeah, they might not be ellipses though. They may not be. That's an interesting question you could ask.
Funky.
Ow.
Is there also like a pattern in which they like start and end on the x-axis?
Yeah, because
Yeah.
they
Like
hit.
the distance between them.
They hit. Well, look at these values. This is going to be pi, 2 pi,
Oh.
3. You see that there's the vertical
Yeah.
tangent lines, right? Where do you think the horizontal tangent lines are?
Still laughing about
Halfway between each one. But you start at pi over 2 and you can jump by 2 pi to get another vertical.
Yeah.
Okay, so there you go.
That's a very cool function.
That's the idea, guys. That's the whole point of implicit differentiation. Well, it's not the whole point, but is you can have these curves that aren't functions. They're these weird, wacky curves, and you can still describe what's it like to move along that curve. What's it like to how do you describe the rates of change along that curve? Let's do one more, if it's okay with you guys.
I guess. I'll allow it in my busy schedule.
You'll allow it? Wow, that's nice of you.
Okay,
Huh?
same, because I couldn't figure it out.
Which one?
Which one?
Sorry.
20.
20?
Yeah, it was mainly that.
Want to come back? We can come back to do 20.
It was mainly that.
Intermission. We'll do 20.
It was actually it was a
Intermission.
really dumb reason why I didn't do it.
Well, Jesse, we had also been sitting at a table for 3 hours trying to do homework, and you had to
That's
deal
true.
with me doing me things.
This is true. That's true.
Did you consider that 1 banana plus 1 banana make a 2 banana?
I did consider that.
Just checking. Just checking.
Yeah, double check. No, yeah, that wasn't the problem. Maybe it is. I don't know.
We're gonna take a. Actually, let's just circle back to 20 at the very end.
Yeah,
makes
let's do
more
that.
sense to me.
What we
Let's
doing
do
in the
that.
second one?
We're gonna follow up on we're gonna do, just don't let me forget to come back to 20.
Okay.
I'll make a little note.
I mean, it'll be fine. I'll eventually
Fine.
figure it out.
Meme number?
It's 21 minus 1.
He said the meme number. That's so savage. God. Okay, let's look at, should we do 33?
Started that song.
I did start it.
Oya,
That's
oya,
your
oya.
fault.
What?
Oya, oya. Let's just do 33.
Yeah.
Oya, oya, oya.
We're probably starting.
Beautiful.
Yeah, we're starting.
Truly.
Okay, just look at it first and go, what is this gonna, did you already get it?
To do the product rule twice.
Very good. So the left side's gonna involve a product rule and then another product rule. So just, it's good to know ahead of time, what am I getting myself into? 2 product rules, not really any chain rules. That's nice. Oh, there is a chain rule here actually, e to the y.
Oh,
But this is gonna be an easy one.
dang.
Remember, we're taking the derivative with respect to x. X is our variable. So, okay, first guy.
First guy.
I'm gonna go, this is my A, this is my B. So A prime times B, cool with that? Plus product rule. My B prime though, is actually, there's a chain rule inside that, right?
Yeah, is it y prime e to the y?
Do we feel okay about that?
Yeah.
Yeah.
And don't forget the X. So this reads, this is my A, this is my B. A prime B plus B prime A. So that first guy was just that, this whole thing was just that guy's derivative.
Mhm.
And then this guy, A prime B plus B prime A. You okay with that?
Mm.
And that equals 2. So,
Those.
Question,
yep,
why didn't we pull the x out and do like x prime times e to the x? And what?
no x prime, because you're taking the derivative with respect to x.
Oh, okay.
So x just behaves as the variable here. If you were taking the derivative with respect to time, so
You're gonna be so
Yeah.
you would have x primes,
Yep.
and that the way you know to do that is if the question said something like, "A particle's moving along this curve, and its x value is changing at this rate," or whatever. You'd see the word time in that question. You'd sometimes say, "Oh, it's moving at 2 units per second or 2 units per minute," something like that. Okay, so anyway, let's isolate. What?
Walking very slow. Don't
Okay.
even listen to me, man.
Look at these two.
Man.
These two terms both have what we want, y prime. So let's isolate that y prime out of that. So you have x e to the y plus e to the x. Cool with that?
Yeah.
And then in the same step, if you're comfortable doing the 2 steps at once, I'm also going to move these 2 dudes to the other side. And I'm just writing, you're wondering, why'd you rewrite e to the xy as y e to the x? That just looks nicer, I think.
Yeah,
More, a little bit more standard.
Yeah.
And then we divide by this. Everyone's okay with that last step? Any
Yep.
questions?
No questions. I've never had a question in there.
Yeah.
That's what Never ask a question ever. Good advice, right?
Yeah.
Uh-huh.
Never seek
Knowledge.
Never seek knowledge. Yeah.
don't seek knowledge. Here in
Knowledge.
my garage in the Hollywood Hills,
No.
my Lamborghini garage. I don't know what this graph looks like. Let's see what it looks like.
It looks fun.
Sometimes you can make these equations and then you look at the
It's like
graph
it's
and it's
just
just
an
like nothing. And you realize that you've made an equation which is undefined. There's no xy pairs that satisfy the equation. So I'm curious to see what this looks like.
Yeah.
X e to the y. I wasn't like that. x times,
Too much.
I think it should kind of be x e to the y plus y e to the x equals 2x. It's not very exciting.
Yeah, that's kind
No.
of lame, man.
Well, it's kind of, it almost just looks like a 1 over x, like a flipped 1 over x, but it has this weird. Desmos cannot tell me where the max is, though. He doesn't want to tell me. Anyway, so in this case, it's just this weird, it's not a function. It fails the vertical line test.
Wow, lame.
What do you mean? It's pretty neato.
No, I'm just kidding. It's pretty cool.
It's pretty neato.
Dude, I think almost everything in math is cool.
That's lit.
Yeah, there are a couple things. We're not talk about that.
Okay.
Need
How are
number.
the feelies?
Good, good, really good.
So
Good feelies. I like this unit.
Gross.
Every unit we've done, so.
what if we schedule the quiz for Thursday? I know you said you wanted to do it Friday, but
Friday, man.
unless you're like pretty far behind,
Thursday's
you can definitely get all this done. I'll post the practice quiz. Normally I would want to do it on Friday, but like we gotta kind of squeeze in the last. I don't want the last week to be like trying to crunch all this stuff in. I think if I shave off a day or two here and there, we'll be able to cover everything.
I have a question. I want your input. So,
Well, let me just hold on.
Okay.
Let me spare Griffin
I thought we were gonna do
from
20.
the.
It is kind of.
Oh,
Does
You
Griffin
need
need 20?
you guys still want to do 20?
I don't care. I mean, we don't have to, but
Well, you don't have to do
Complete
anything. You don't
page.
have to do anything, right, Griffin? Free will doesn't exist. It's just.
Yeah, like in.
yeah, Griffin did. Yeah, you want to hear more about my IUD? Griffin? I'm sure he's fast. No, he's probably not listening live. No, he's caught up to this unit. Oh, didn't they go to Spokane or did he not go?
We'll do
No,
20.
he didn't go. Okay, well, never mind then. Hi, Griffin. He and I went out to a nice little
Oh,
coffee
right,
yesterday.
right.
20 was.
Good.
Goodness.
Buckets.
Watch this right over Aspen's head.
No, it doesn't even have the cap on it.
Boom!
God.
Double buckets! I just sunk both of those. Both went in.
Well done. I'm glad that it amused you, Trent. That's what I wanted.
Okay.
Amused Trent. Yes.
20.
20.
Kids going
Jeez.
to calm down.
Yeah, I know. I heard. I skied with your parents, Scotto.
Yeah, I know, I heard.
Okay, so just says where does this graph increase and decrease? It's definitely a weird graph. Just before we start, I mean, I think it's worth understanding that because like the log function looks like this, and the x squared function, that one is a famous, function. So if you divide these, if you go these y values divided by these y values, firstly, you're not going to get a left side anymore. And what do you get when you, same kind of weird question of what's going to happen when you have these tiny positive x values. Sorry, I meant to say at these tiny positive x values, you have tiny positive y values divided by enormous negative values.
Yeah.
Right? But that one's, let's see, is that a confusing one? A small number divided by a huge number,
Huge.
where one is, the bottom is negative, that's gonna yield what kind of number? Just a wee lad. So we should expect little wee lads here.
Wee lads.
And then what happens as x gets big?
Funky chop, man.
Is there gonna be an asymptote on this?
No,
No.
What about at 1?
maybe.
Log hits
Oh,
Zero when x is
Sorry,
1.
sorry, man.
So I
Yes.
think that there's going to
One.
be, at least I have suspicion that at x equals 1, there's some funny business there.
Some funny business.
So I don't know. I'm thinking this is just just kind of supposing here, but I think that supposing.
Apparently.
I know that these have to be negative numbers. So I'm thinking this maybe it's something like that one we did the other day where there's like a hole and it goes starts off small and negative and goes along the asymptote. And on the other side, you have numbers divided by tiny numbers at first, but they're all positive. But eventually this x squared is gonna dominate the log, because x squared grows really fast and log does not grow very fast. So I'm guessing it's gonna do something like this. But again, do you have to do all that before you do the problem? Nope.
Nope.
I think that's the fun way to do it. There's lots of fun thinky winkies you can do. So now if that, just pretend we didn't have that. See, how could you have gotten this or something like this from the calculus techniques? Okay, so first thing, it's which rule? Quotient rule. Anything else is gonna make it harder than it needs to be.
Yeah.
So I'm gonna go, so my A over B turns into A prime B minus B prime A, right?
Yeah.
So
Over
all over B squared.
B squared, yeah.
So the bottom's gonna be log squared,
Yeah.
Yeah. and then the top's gonna be A prime,
2x times 1, natural
A
log
prime
of
B.
x minus 1 over x times x squared. Yeah, x squared.
Great.
A lot of numbers being. Yeah.
Let's simplify that a bit so it's a little bit nicer to look at. I noticed that I've got,
Funkiness.
I mean, we could factor out the, I know there's gonna be an X here.
Yeah.
We could factor out the X.
Why would you do that? Oh, okay.
It seems like it makes,
Yeah, sorry. I did
Beautiful sense,
actually. I actually factored out the x, and I still asked you for some reason, but it's right here in my
do you
paper.
feel good about that?
Yes.
Yeah,
Okay,
that's what I have.
so now we have to identify, this might require some margin work, a little bit of scratch work, because that's not super easy.
Yeah,
but
that's
this
where I
one-
got stuck.
We know that 0 is relevant, well, for two reasons.
Yeah.
0 is the lower bound for X values, and
One
then
is
we've got, what?
You say 1.
And then 1, yeah, 1 would make the bottom 0, so 1's relevant. And
Is that
then,
1 over B squared?
See, I got.
let's see, let's set that equal to 0. So the other question is, well, what would make this term be 0? This is where maybe you go into the margin. That's probably worth showing your work.
Oh, so it's whatever makes natural log of x equal 1
Minus 1 equals.
right?
So solve this, you get log of x equals 1/2.
Right.
So x is e to the 1/2 power. What's e to the 1/2 power?
Whatever is- Oh,
The square root of e.
Square root of e. I was close.
Which is that bigger or smaller than 1?
It's smaller. A bit
E is
smaller.
like 2.7. The square root of 2.7 is going to be certainly bigger than 1.
Dang.
Oh, that's pretty.
No.
That's a nice number.
That is a
The
nice
square
number.
root of e.
All right.
Yeah, that's a
Okay.
nice number.
Yeah. I
No.
Don't at me, bro.
Well, this is another one of those moments where I was like, Jesse, you could have done
It's
this.
a pretty number.
But whatever, it's fine.
It is.
I just forgot.
Compared to like,
divide.
what, what is your?
2.
Yeah. Isn't that a beautiful?
Oh, 2 is kind of a boring number. This is a nice
That's
number.
a completely different description.
It's the square root of e.
Yeah, and E is one of the most beautiful numbers
He
because
bussin'.
it's just he
No, I like
doesn't.
square root
Exactly.
E better than E.
He bussin'.
That's the best meme word nowadays.
Bussin'.
Okay, so we understand this? We sure?
What about sheesh? You're
I
right.
understand that, but where did the 1 come from?
Well, you're always, remember your y prime number line, you're always checking for not only what makes this equal to 0, but what makes it undefined, right? Because what makes this undefined, and any x value that makes this undefined is going to tell you about maybe like a pointy or an asymptote or something like that, or maybe a jump in the graph. So in this case, I'm pretty sure I'm feeling maybe that's an asymptote. So anyway, let's check the intervals. So if x was between 0 and 1, this is where it's a little tricky, but the bottom luckily is squared, so I can kind of ignore it. The bottom's always positive, except when it's 0, that one time.
Except when it's not.
Well, I'm saying it's positive for all x values in the domain. Well, that's true, actually. It's positive for all x values in the domain.
Mhm.
Just that there's a certain number in the domain 1 that makes it undefined. So anyway, if so looking at this, if x is really small, then this is a negative number, right? If x is between 0 and 1, then the log is negative. Negative minus 1 is still negative. So So the whole thing would be negative. Does that make sense?
Yep.
Which indicates to us that our function is decreasing. Which,
Do we have to write out the intervals, or can we just show this thing in the Wiki?
right there.
Okay. Just wondering.
There's actually a thing that's a weird thing on the AP exam that they don't consider the number line to be adequate justification for like where there's a local max, for example. You actually have to say a statement like the derivative is changing from increasing to decreasing, which I think is really silly, but anyway. So between 1 and root e, so we established that root e would make this equal to 0. So if you were a bit smaller than root e, this would be negative. Does that make sense? That's a bit of a tricky argument to make, but it's right. We know the log function is always increasing. So if we have the value that makes this equal to 0, and if you go a little bit smaller, it'll be negative. So you don't see those a ton when you make a number line, right? Decreasing, decreasing. But what explains that is that there's an asymptote there, right? At an asymptote, you can go from decreasing to decreasing, right? And then if x was larger than root e, this would be positive. So, the question is just asking what are those intervals. So you might say, okay, well, just write your answer. You say, okay, from 0 to 1, union from 1 to root e, we are decreasing. Sorry, I know it's feels a little redundant to after you had this, write it again, but it's good practice. Increasing, I misspelled increasing. Increasing is from root e to infinity. All right, bye everyone. Have a good day.
You
Keep it lit out there.
We.